Hey guys, welcome back to Taylor's Series Lesson 7. So in the last video, I showed you guys what to do when you have a function that you can't take a lot of derivatives of because it just becomes too complicated algebraically. So take a look at this function right here. Can you imagine? You can take the derivative using the quotient rule the first time, and then once you try to clean it up, it's probably going to be a quotient, a product, and a chain all together. Oh my. So what are we going to do when it's too challenging to take derivatives of? Well, you're going to remind yourself that you have 1 over 1 minus r. Okay? And when I say 1, I really, again, should put a1. But here's what I'm going to do. I'm going to say this is 2x, leave it alone. I have that 1 there that I want. I'm going to do this here. That's how I'm going to maneuver it. What you guys notice is that minus minus is a plus. And then I'm just going to wrap him, okay, with that red paper. Okay, so 1 minus x squared. And now I have my r that I want, and I have my 1 that I want. Some of you are like, wait, what about that 2x? We can leave the 2x out for now. So here's what we're going to do, guys. We're going to remind ourselves that 1 over 1 minus r is equal to 1 plus r squared plus r to the third. And I'm going to stop there because it says write the first 4 non-zero terms, okay, and the general term. So this is what we do for the general term, okay? We just do that. Now, all I'm going to do is I'm going to substitute every place I see an r with a negative x squared. Okay, so I have 1, and then I have plus negative x squared plus negative x squared squared plus negative x squared to the third plus dot 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 plus negative x squared to the n. Okay, that's wonderful. So then I have 1 minus x squared plus x to the fourth, right? Minus x to the sixth plus, and now we have an alternator in there, but that's fine, I guess, plus negative 1 to the n, 2x to the, sorry, negative 1. Maybe I should just leave it for now until the very end. I don't know where, sorry, excuse me, right there. I gotta get rid of this. I'm gonna leave that till the very end. Plus, dot, 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 negative x squared to the n. Okay, so what we did there was we just substituted negative x squared for the r, okay? Now I gotta come back here and I have to take care of this 2x. So what I'm gonna do in this case is I'm just going to multiply everybody by 2x. So 2x times 1 is 2x, minus 2x times that guy is going to be 2x to the third. Then this is going to be plus 2x times x to the fourth is 2x to the fifth. And then minus 2x to the seventh. This is why I wanted to wait here. So I'm going to get negative 2x. Now remember, this guy is to the first, okay? And this guy is x to the 2n, so when we combine them, it's going to be x to the 2n plus 1, okay? So I'm going to write the last term right here, negative 2x to the 2n plus 1, but we have an alternator, so we can't leave that negative just like that. So I'm going to say negative 1, I'm going to get rid of him. Okay, let me get my small eraser. And then I'm going to just say to the n. And then you are basically done with part A. So once again, I have a complicated function, or a function that it's complicated to take many derivatives of, and I have to get it to look like 1 over 1 minus r. Once I do that, and I figure out what the 1 and the minus the r is, I substitute it. At the very end, you take the whatever's left over and you're going to multiply it by it. And so this is your first, second, third, fourth, and your final term. So I'm just going to get rid of this guy here. I was just trying to show you the math behind it. All right, so that's basically how you do it. And let's take a look at part C in this case. So part C says the derivative of the natural log of 1 plus x squared is 2x over 1 plus x squared. That's the function that we just found. It says write the first four non-zero terms only for ln of 1 plus x squared. Now, this is the great thing about stuff like this. If you just wrote, I wrote it like this because we're going to integrate, and it's silly to integrate with 2x over 1 plus x squared. We're going to exchange those variables for t. That way, when we're done integrating it, we'll substitute the x, and then, of course, with the 0, it'll just cancel out. So this guy here is basically what we just found. Okay, so that's this here. But now I'm just putting it in terms of t. And it's so wonderful because what you just found out is, okay, so we got 2t squared over 2 minus 2t to the 4th over 4 minus 2t to the 6th over 6 minus 2t to the 8 over 8. We're going to plug in our x. And after, let me just do it here and just be done with it. And then you're just going to get x squared minus x to the 4th over 2, so 1/2 x to the 4th. We have 1/3 x to the 6th and minus 1/4 x to the 8th. And what that is equal to is basically the natural log of 1 plus x squared. So the thing that I want you guys to realize about this is that sometimes you'll be given something like this and to find the Taylor series for, okay? So like find the Taylor series for this guy. He might be too challenging. What you want to do is you might want to just take the derivative once, get this, figure it out using the power series that we just did or the geometric series, and then go back and integrate it, and then you'll get this guy back. So that's how we do this problem. I hope you guys enjoyed it.